Today's topic is dimensional analysis. We're going to focus on one-step calculations. Let's take a look at our first example. Marathon runners race 26.2 miles to reach the finish line. How many kilometers is this? So we're looking at converting miles to kilometers. This is a conversion from English to metric. So the first thing we need to do is figure out where our conversion factor is. How many kilometers equals miles, or how many miles equals kilometers? For our purposes, we'll go ahead and use 1 mile equals 1.609 kilometers. Since this is an English to metric conversion, you're not responsible for having this memorized. You'll always be provided with these conversion factors from English to metric on tests and quizzes. We're going to start by setting up our given value. So we're given 26.2 miles. So that's the value that we start with. And since we want to eliminate miles, we want to cancel out the miles, we're also going to put miles in our denominator. So if we put miles in our denominator, that means the kilometers, the label that we want our answer to have, will be up in the numerator section. And for dimensional analysis problems, the label that we want our final answer to have will typically appear in this spot. So we're given 1 mile equals 1.609 kilometers. So we're going to plug those numbers in. So 1 mile equals 1.609 kilometers. So that's something to note about conversion factors. The quantity that's in the numerator will equal the quantity in the denominator. They have that equivalent relationship. Now, you treat these numbers the way you treat fractions. So numbers or values that are in or the numerator, they will be multiplied and then divided by whatever's in the denominator section. So for that reason, the miles will cancel. Now, we're going to go ahead and multiply 26.2 times 1.609. And that gives us 42.1558. Instead of writing that entire value down, we're going to limit ourselves to significant digits based on the value given to us in the problem. So we're given 26.2 miles. So that means that we have 3 significant digits that we want to record in our final answer. So we're going to round the calculator answer to 42.2. Remember, the 1 rounds up to a 2 because of the 5 that follows it. 42.2 kilometers. If the instructions asked you to record this value in scientific notation, remember you would simply move the decimal point over 1 place to the left, so it's right after the 4. And when you do that, remember, you would have a positive exponent, or you would add to your exponent. So you'd have, so it would be 4.22 times 10 to the power of 1 kilometers. Let's look at our next example. Number 2, Let's Go Airlines, that's a fictional airline, allows 23.0 kilograms of checked luggage for international flights. How many pounds is this? So once again, we have a metric to English conversion, kilograms to pounds, and you're not going to be responsible for having this conversion factor memorized. It'll be provided for you. So we're going to be using 1 kilogram equals 2.2046 pounds. So once again, we start with 23.0 kilograms, our given value. We want to eliminate the kilograms, so that's going to go in the denominator and convert to pounds. That will be in the numerator. And plug in your numbers. So 1 kilogram equals 2.2046 pounds. Okay, the given unit cancels, and you multiply the top. So 23.0 times 2.2046. And that comes out to 50.7058. Once again, we have 3 significant digits in our given value. So we're going to round our final answer also to 3 significant digits. So 50.7 pounds is our answer. If the instructions ask you to change your final answer to scientific notation, then again, you would move the decimal over 1 place to the left. Remember, there's only 1 integer, non-zero integer allowed in front of the decimal when you're recording numbers in scientific notation. Since we're moving to the left, we would add to our exponent. So our final answer comes out to 50.7 pounds, or 5.07 times 10 to the power of 1 pounds. Example number 3 states that Fort Knox houses 4.1759 times 10 to the power of 9 grams of gold. How many kilograms of gold are in Fort Knox? Here we're given units that are within the metric system, grams to kilograms. You are responsible for knowing how many grams is in a kilogram or vice versa. Let's bring in a little table of prefixes that hopefully is familiar to you. These are metric prefixes that are listed from greatest to least. You'll notice the base unit is in the middle here. So we're dealing with grams this time, that's in the middle. And kilograms is our prefix, kilo is our prefix. So the way this works is, for consistency's sake, I'm going to always assign in our conversion factors the prefix, I'm going to always assign it a value of 1. So 1 kilogram will then equal 1,000 grams, or 10 to the power of 3. So that's our conversion factor. 1 times 10 to the power of 3 grams is in 1 kilogram. Let's go ahead and plug this in. So starting with our given value, 4.1759 times 10 to the power of 9 grams. We're going to get rid of grams. That's going to go down the denominator, and we're solving for kilograms. And now we're going to plug in our conversion factor. So 1 kilogram equals 1 times 10 to the power of 3 grams. Now, if you remember what to do with exponents when dividing, we subtract exponents. So 9 minus 3 equals 6. So positive 6 will be our exponent in our final answer. Multiplying across, we still have the same number, because other than our given value, all of the other numbers present in this setup are all 1s. So multiply by 1, divide by 1 is the same thing. 4.1759, that's 5 significant digits in our given value. They will also be retained in our final answer, times 10 to the power of 6. The grams cancel, so we end up with kilograms in our final answer. Just to verify, let's go ahead and solve this on our calculator. So 4.1759. This number has an exponent, so look for the EE key on your calculator for exponent. 9 divided by 1 exponent 3 equals, look at that huge number, 4,175,900, and there's your decimal point. To write this in scientific notation, you need to move this decimal point over 1, 2, 3, 4, 5, 6 places to the left. Since we're moving left, remember we need to add to our exponent. So that's why we have 6 in our exponent. Example number 4 says the average human blink lasts 100 milliseconds. What is the length of time in seconds? So once again, we're in the metric system. We're using the metric system. This is a conversion that you would be responsible for. Let's bring in our table of prefixes. So seconds is our base unit. Seconds would be over here as our base unit. And milliseconds, that would be right here. And if we stick with the prefix gets the 1, then we would say 1 millisecond equals 1 times 10 to the power of negative 3. That's a negative 3 exponent seconds. So that is going to be our conversion factor. Let's begin our problem. 100 decimal point. That means there's 3 significant digits in this value. 100 point milliseconds, the abbreviation or the symbol for that is just lowercase m, lowercase s. We want to get rid of milliseconds, so that's going to go at the bottom. And we want to retain seconds as the unit for our final answer. 1 millisecond equals 1 times 10 to the power of negative 3 seconds. So you can see that milliseconds will cancel. And if you recall, 100 is the same thing as saying 1.00 times 10 to the power of 2. That's the same thing as saying 100. So if you recall what to do with the exponents here, we're multiplying the exponents. So 2 plus negative 3. Remember to add the exponents when you're multiplying. That equals negative 1. So that will be the exponent in our final answer. 1.00, that's 3 significant digits, times 10 to the power of negative 1 seconds. Let's use our calculator to verify. So I'm going to stick with the 100 times 1 exponent 3, look for the negative sign, equals 0.1. 0.1. So remember, when we write this in scientific notation, the decimal needs to be moved over one place to the right. When we move to the right, we make our exponent negative, okay? And there's 3 digits in our final answer because there's 3 digits in our given value. Our final example is for honors chemistry students. There are approximately 50.0 microliters of blood in a single drop. How many liters is this? So since we're dealing with microliters and liters, this is within the metric system. You're responsible for knowing this conversion factor if you're in an honors chemistry course. Let's bring in our table of prefixes and find microliters and liters. So liters would be our base unit, so that's right here. And micro is all the way over here, okay? So our conversion factor then, if the prefix gets the 1, is 1 microliter equals 10 to the power of negative 6 liters. Let's begin. 50.0 microliters. We want to get rid of microliters, so we're going to put that in the denominator. And we want to have liters in our final answer, so that'll go up at the top. 1 microliter equals 1 times 10 to the negative 6 liters. And remember, 50.0 is the same thing as saying 5.00 times 10 to the power of positive 1. Okay, so that allows you, I keep doing those conversions so you're able to do some mental math here. So 5.00 times 10 to the, can you do the exponent calculation? We're multiplying, so that means we're going to add the exponents. 1 plus negative 6 equals negative 5. So that would be our exponent, negative 5 liters. Let's make sure our units cancel, and they do. And let's also work this out on our calculator to make sure our work came out correctly. So 50.0, our given value, times 1, let's find the exponent key, EE, 6, it's a negative exponent, so make sure you hit that button, equals, okay, our calculator answer comes out to 0.00005, but if the instructions ask you to write this in scientific notation, you need to move the decimal point over to the right to make sure it's after the 5. So we're going to go 1, 2, 3, 4, 5 places to the right. Since we're going right, remember, we have a negative exponent. And we have 3 significant digits in our final answer because we had 3 significant digits in our given value. So that's it for one-step dimensional analysis. Watch the next video for two-step dimensional analysis problems.